My name is Amit Giloni. I'm a principal researcher at Fujitsu Research of Europe in the Generative AI Trust team. And today I'm going to talk about how to rank the different agents in multi-agent systems and understand their influence. So at the end of the day, who is really in charge of the final output? So I will not say what is AI agent. I think after this day, everyone knows. I will just say that for complex and multidisciplinary tasks, several AI agents can be used in multi-agent system together in order to solve a shared goal. So, who is really in charge? We have several agents who can actually affect the final output and how and in which task. This is an important question for several reasons. First of all, we need to understand it from the quality perspective. If we don't understand how the system is actually operating and which agent is actually affecting the final output, it can derive several bugs, a lot of issues. So it's important from the quality perspective. In addition, we need to understand it from the observability perspective. If we know what actually happens, we can understand better the system and make more concrete decisions in order to produce a better multi-agent system at the end of the day. And of course, we have also the security perspective. So if we understand who is actually affecting the final output, we can target this specific agent and add security mechanisms only to this agent. So I will take this use case of security in order to understand the importance. So when we have agentic AI workflows, multi-agent systems, it's the same thing. We have a higher autonomy. Higher autonomy leads to a higher security standards because the system can do a lot more things than a regular system. Higher security standards means, at the end of the day, applying more security measures, which means that we have additional added latency to the inference time of the system. So if we take it, for example, this very, very simple multi-agent system, we can see that if we apply some kind of a security guardrails, some kind of a, I will simplify it, some kind of a guard in order to prevent the agent to do stuff that we don't want it to do. So basically we will add X seconds to each agent operation. So by the end of the day, we will have 3x seconds added latency to the entire system. But if we actually know which agent actually influenced the output before the inference time, we can identify potential failure points in the system pre-inference time, which means that we can apply targeted security on the specific agents that actually interest us in this scenario. And it means that we will substantially reduce the latency at inference time. In the very simple example, here it means to reduce from 3x seconds to x seconds. So we understand it's important, this task, but how do we do it at the end of the day? So there are several techniques that can be applied from different domain, different fields. However, they are not suited for agentic AI workflows. For example, stuff from the connectivity graph theory can be applied on agentic AI workflows, but it means that we only analyze the structural information of the agentic AI workflow and not the actual behavior, and not the actual outputs of the different agents. In addition, such solutions are not suited for the flexibility of the agentic AI workflows. Not all the time, all the agents are activated in the same order, in the same internal loops, and such things. So if you just counter for the structural part, you miss all the flexibility. And in addition, solutions such as human annotation is not something that is visible at inference time, basically. So in Fujitsu, we suggested a technique called CAIR, Counterfactual-based Agent Influence Ranker. CAIR basically performs two phases, the offline phase, which means that CAIR takes the agentic AI system and analyze it in order to understand the different connections between the different agents. Pre-inference, it's offline. And in offline, at inference time, we actually can do a very simple lightweight technique in order to understand from the offline phase results the actual rankings of the different agents for this specific query. So, start from the offline phase. I will do it very quickly. So the offline phase actually gets the agentic AI workflow quite given and a set of representative queries. Those representative queries actually mimic the different use of the entire system. And by using the agentic AI workflow and the set of representative queries, we can deduce at the end of the offline phase a score for each agent, how it's influenced in this specific representative query. So before diving into how, let's talk about the intuition behind it. So CAIR's offline phase is quite influenced from the feature importance fields in regular machine learning. It's quite inspired by specifically line technique. And we actually parallelized the different components of agentic AI workflows into the regular feature important field of regular machine learning. So if we will parallelize the machine learning model to the agentic AI workflow, so basically the output of the machine learning model, which is what we want to explain at the end of the day, is the output of the agentic AI workflow. Quite simple to understand this parallelization. So by taking this parallelization, we can actually parallelize the agents to the data features, which means that the outputs of the agents are the data features values, which means that we can derive and leverage techniques from the feature important field into actually doing the same thing, but for agents. So the offline phase actually contains two phases. The first one is a workflow variation recording, which means that we take each representative query, record the workflow activations, and for each agent output, we actually established some kind of a counterfactual output, which means the most different output that is still a valid output for this specific agent. By that, we have some kind of different variations of the same workflow for the same query. We take all those workflows, and at this time of day, I will not go into the math. So we take all those variations, counterfactual workflow flows, and aggregate their differences into a specific influence score. We take into account the agent location in the flow, the different perturbations that we actually did, and the entire flow changes. After having those scores from these differences, we can actually, at online phase, understand to which representative query the actual query from the inference phase is the most similar to. So we can deduce the different ranking, deduce the different rankings from the offline phase into the online phase. So I will not go into all the different evaluations we did about it. It's not that interesting. I will just say that we evaluate this technique on 30 different agentic AI workflows, on 3 different types of workflows that are quite common. The sequential flow, router, and the orchestrator multi-agent systems. And we evaluated 230 different tasks. The evaluation said that CAIR rankings are quite okay. You can see all of it in the paper if you want. But for our specific use case, for example, the targeted security scenario, we showed that when using the different rankings that CAIR actually produce, first of all, the agentic AI workflow works the same. It works at the same inference time, quite similar inference time, obviously, but the effectiveness of the different guardrails, here specifically it's toxicity guardrails, actually did not reduce, which means that the security of the system remains the same, with no substantial added latency. So it was a lot for this time of day, but what you can take from all of this. First of all, in agentic AI workflows, not all agents are born equal. It's quite given. Not all agents actually affects the same on the specific, on different queries, on different tasks, and stuff like that. And in addition, a better understanding of the agentic workflow can actually lead to a better agentic workflow from the security perspective, the quality, and the observability. Thank you. Any questions? Yes.
So you said you're constructing a representative queries beforehand for the offline gathering of the importance of the different factors. So my question is, does the user provide these queries? Where do they come from?
Yeah, so the representative queries can be set by the user, but in addition, we showed that we created a technique in order to generate them beforehand, so the user can actually just give the agentic workflow, and we can generate the representative queries that we need. Any more questions? Okay, thank you.